Hey Robert, how are you? This is Chris Gerow. I got curious about your little project, and so I decided to model it and let's take a look at what I found. Um, in the process, I made a series of assumptions. Um, One of the assumptions is that the throwing arm is 30 pounds. That's the weight of the throwing arm. The weight of the counterweight arm is 20 pounds. Uh, my um, my counterweight is actually 100 pounds, and my payload, which in my case is a pumpkin, let me get to that. I'm going to have to go in a little bit here. Um, my pumpkin is 3 pounds. Okay, so it's a fairly small pumpkin. Um, Again, this is not a very big machine either. The throwing arm in this case happens to be um, the length of it is 7.2 feet. Um, Again, these numbers were just pulled out of a hat. There's nothing scientific about it at this point. But I just want to get a flavor for what would actually happen during the throw with your double hinge. Now, I put in a block in here on the double hinge so that this will repel this, and that'll keep it in place. I put a block above it. Let me go back in there a little bit. See this block down here? This will prevent the hinge from collapsing during the beginning of the throw. And then the fact that it's up against this piece in the back will prevent it from collapsing the other direction during the throw. At any rate, this may or may not be valid for what you're trying to do, but that's what I ended up trying. As I go through this, the first part of it is fairly unexciting. Let me go back to here. The hinge now has allowed this to become free, and the hinge is actually resting against this block. So it's starting to really pull at this point. Now the as the pumpkin, as you can see, has been released from its block. And let me move this thing out a little bit. No. So I can see what's going on. It continues on until it gets to about here. And I think the counterweight at that point has pretty much hit the end of its throw. Now, this happens to be exactly where the power part of the throw is occurring. And so it's the inertia of this whole mechanism that's causing it to continue. It's certainly not being pulled by the counterweight. So you see the counterweight is almost stopped at that point. The weight of the throwing arm is causing it to go forward, and it finally releases at 96 miles an hour. Okay, this is my first attempt at trying to simulate your situation. If you want, you can validate what I've done, and we can make changes and try it again. Thanks.